Hello students, good time to all. I am Chandan Kumar Pradhan. Welcome to your YouTube channel Chandan Physics. In this video, we are going to discuss partial derivatives. Let's begin. Partial derivatives of function of several variables is obtained by taking the ordinary derivative with respect to one of the variable, keeping the remaining variables as constant. Means partial derivatives of functions of several variables. It indicates the function is of more than one variable, that is either 2, 3 or and so on. Then we treat it as several variable. The function of several variable is obtained by taking the ordinary derivative with respect to one of the variable, keeping the remaining variable as constant. One variable taking as constant and we get the ordinary differentiation with respect to that another variable. Let's it can be easily explained with the help of an example that related to function of more than one variable. We consider a function that is of two variable. If z is a function that is a function of xy, that is a two variable function, z is equal to f of xy, be a function of two variables in x and y, then we treat y as constant. We treat y as constant and vary x. Then derivative of z with respect to x, keeping y as constant, is called the partial derivatives of z with respect to x. Z is equal to f of xy. In that case, if we differentiate z with respect to x, whereas y treated as constant, then we tell that is the partial derivative of z with respect to x, whereas y treated as constant, then we write it as partial derivatives of z with respect to x when y as constant. What should be the writing procedure? We write it as del z by del x or del f by del x or f of x comma y, f lower subscript x, that is a function of xy, or d of f lower subscript x, d of x of f. This meaning is partial derivative of z with respect to x when y as constant. That indicates this. Also, these are the symbols for writing these partial derivatives of z with respect to x where y treated as constant, indicates the symbolic representation, that is the symbolic representation of this. Again, if we define what is the mathematical criteria, or in which way in mathematical definitions we find out the partial derivatives of z with respect to x, del z by del x, we use the basic definition of differentiation, that is limit delta x tends to 0 f of x plus delta x, a small increment in x, y minus f of xy divided by delta x. This is the basic definition of that of partial derivatives. What is that partial derivative? The partial derivative was, that is the partial derivative of z with respect to x, whereas y treated as constant. Again, if we write it as partial derivative of z with respect to y when x as constant, then the symbolic representation looks like this. Write partial derivatives of z. The function is z is equal to f of xy, that is a two variable function. The partial derivative of z with respect to y when x treated as constant. Then what is the symbolic form? Then the symbol should be del z by del y, or del f by del y, or f of y xy, that is the function, or d lower subscript y of f. These are the some symbols that represents the partial derivative of z with respect to y when x as constant. Again, we can mathematically represent this by using the definition of differentiation. We can also write del z by del y limit delta y tends to 0. In that of case, small increment in x, particular that case small increment in y, f of x y plus delta y small increment in y minus f of xy divided by delta y. This is the partial derivative of z with respect to y, whereas x treated as constant. This is the basic definitions of partial derivatives. How we can get the partial derivatives of the functions that is based upon two variables. Let us find out some derivatives that related to partials, that is of higher orders. So let us discuss partial derivatives of higher orders. Partial derivatives of higher order. Higher order in the sense we again differentiate with this to another function, or let our function is z is equal to a function f of xy, that is a two variable function. Then del by delta x of del z delta x, that is the partial derivative of z with respect to x, sorry that is x, partial derivative of z with respect to x, whereas y treated as constant. Again differentiate this with respect to x, that becomes, we represent this as del square z divided by del x square, or we can also write del square f by del x square, or f x x, partial derivative of x, again we differentiate with respect to x, differentiate with respect to x, then the lower subscript like x x. This is the representation of the higher order differentiation. Similarly, another forms of higher order partial derivatives are represented like this: del by del y of del z by del x. We can write it as del square z by del y del x. This can also be represented del square f by del y del x or f of yx, del y del x f of yx. That means this is the representation of this partial differentiation of higher order. Again, another form, these are the forms of higher order partial derivatives. If we differentiate del by del x, del z, del y, that is del square z, del x, del y, representation looks like del square f divided by del x del y or f of xy, del x del y xy. Again, del by del y of del z by del y, del square z divided by del y square, or the representation looks like this, del square f divided by del y square or f of y y. These two are very similar. F of yx is equal to f of xy. So these representation are named as second order derivatives, second order derivatives of a partial differentiation. This representation is named as second order derivatives of partial differentiation. Noted that these two, what we call before, del square z by del x into del y is equal to del square z divided by del y into del x. These are equal. F of yx is equal to f of xy. That means when we interchange del x and del y, the value is remains constant. This is the partial derivatives of higher orders. We take as example of second order derivatives of partial differentiation. Let us again we discuss variable to be treated as constant. Variable to be treated as constant in partial differentiation or in partial derivatives. So we can write variable to be treated as constant if we consider polar coordinates. Let x equal to r cos theta, that means r is equal to x by cos theta and y is equal to r sin theta, that means r is equal to y by sin theta. Then del r by del x, that is the partial derivatives of r with respect to x, whereas theta treated as constant, that means what we call it as partial derivative of r with respect to x, keeping theta as constant, keeping theta constant. That is in the relation r in terms of x and theta, r in terms of x and theta. We can find out r is equal to x by cos theta and r equal to y by sin theta. Therefore, x square plus y square is equal to r square. X square plus y square means r square cos square theta plus r square sin square theta. When we take r square as constant, that is cos square theta plus sin square theta is equal to 1. That means that equation becomes x square plus y square is equal to r square, and r is equal to x sec theta, that is x by cos theta, that is x sec theta. 1 by cos theta equal to sec theta. Again r equal to y by sin theta, we also write it as y into cosec theta. So let us find out the differentiation. Therefore, we differentiate del r by del x, that is differentiation partial derivative of r with respect to x, whereas theta is constant, we write it as sec theta. R sec theta with respect to theta as constant, that means sec theta del x by del x is equal to 1, that is differentiation of r, that is partial derivatives of r with respect to x when theta is constant, is equal to sec theta. So del r by del y when theta is constant, that is y by r equal to sin theta. Similarly, differential partial derivatives of r with respect to y, whereas theta is constant, then the value is sin theta, not sin theta, that is cosec theta. What we call it is cosec theta. Okay, that is sin theta. Okay, also we can write del by del x means del by del x lower subscript y derivative with respect to x, whereas y treated as constant. If that y does not retain, it means that is del by del x indicates del by del y, del by del x as y treated as constant, and del by del y mean del by del y x treated as constant. This means that. Similarly, we also write del by del r means del by del r theta as constant, and del by del theta means del by del theta, whereas r theta is constant. Okay, these are the some standard writing symbols of these variable to be treated as constant in the higher order partial derivatives. So let us take two examples regarding our partial derivatives, one from partial derivatives of higher order and another from variable to be treated as constant. Let us take some examples and how we solve these problems by using our concept. So the question is, find the first order partial derivatives of the function is given u is equal to e to the power x sin y. Very easy question. U is equal to e to the power x sin y. How we solve it? Given u is equal to e to the power x sin y, therefore u lower subscript x, that means partial derivative of y with respect to x, whereas y treated as constant, that is del by del x e to the power x into sin y with respect to x, y as constant, that means e to the power x sin y. Again u of y is equal to del u del y del by del y function e to the power x into sin y is equal to e to the power x cos y. Differentiation with respect to y, x treated as constant. This is the answer. First order partial derivatives we find out of that of given function u is equal to e to the power x sin y. Again we solve another question. If u is equal to y by z plus z by x, so that x del u by del x plus y del u by del y plus z del u by del z equal to 0. We can show this as 0 when the function u is given by. Then we find out the solution, how we can prove this as 0. First of all, we find out del u by del x, del u by del y and del u by del z. Again we solve this and prove what should be the actual value of the given result. Del u by del x is equal to, we differentiate that function with respect to x, whereas z and y are constant, then we find that is z by x square. Again del u by del y, del u by del y, and differentiation, the partial derivative of u with respect to y, whereas x and z are constants, so the value is 1 by z. Again del u by del z, del u by del z, that is equal to minus y by z square plus 1 by x. Now we find out del u by del x, del u by del y and del u by del z. So we put these values in that of a particular equation, then therefore we write del u x into del u by del x plus y into del u by del y plus z into del u by del z. Put the values x into minus z by x square plus y into 1 by z plus z into minus y by z square plus 1 by x. We can solve it as minus z divided by x plus y by z, it is minus y by z plus z by x. Cancel out, the value is 0. So you prove it as by using this function or the concept of partial derivatives. Again we also solve a question regarding the variable to be treated as constant. Let the question is, that question is based upon the variable treated as constant. That question, if z is equal to x square plus 2y square and x is equal to r cos theta, y is equal to r sin theta, then find del z by del y, whereas r is constant, and del z by del theta, whereas x is constant. That means del z, that is partial derivative of z with respect to y, whereas r constant, and partial derivative of z with respect to theta, whereas x constant. We find out these answers by using our variable to be treated as constant concept. What is that concept? We have x square plus y square is equal to r square. Given is x equal to r cos theta and y is equal to r sin theta, that is x square plus y square is equal to r square. Tan theta is equal to, we divide this, sin theta by cos theta, that is tan theta is equal to y by x, which implies y is equal to x tan theta. We find out two relations, that is x square plus y square is equal to r square and y equal to x tan theta, that is y in terms of x and theta. We can write as z equal to x square plus 2y square, putting x square is equal to r square minus y square, x square is equal to r square minus y square, put in that of equation, we get z equal to r square minus y square plus 2y square, which implies z is equal to r square plus y square, which implies the partial derivative of z with respect to y, whereas r treated as constant, and differentiation of z with respect to y, r as constant, that means that is 2y. This is our one result. The question was find partial derivative of z with respect to y whereas r constant. We also find out the result partial derivative of z with respect to y where r as constant. This is the first answer of the question. Next we find out the partial derivative of z with respect to theta whereas x is constant. Then we write also we know z equal to x square plus 2y square, that is equal to x square plus 2x square tan square theta. In place of y square, y I write x tan theta. Therefore del z by del theta of x, that is partial differentiation of z with respect to theta whereas x as constant, is equal to 2x square to tan theta into sec square theta is equal to, that is 4x square tan theta. In place of sec theta I can write r by x, that is r by x square, whereas sec theta is equal to r by x. Then 4 r square tan theta, x square cancel out, or del z by del theta whereas x as constant. This is the second result of the given question. Then we find out these two results by using the concept of variable to be treated as constant. So in that of entire video lecture we discuss the concept of partial derivatives and how we write the partial derivatives, and by using the definition we mathematically represent these partial derivatives and some symbolic represent, and partial derivatives of higher orders, that is we take an example of second order partial derivatives or the second order partial derivatives of partial differentiation, and we take a note, that is del square z by del x del y is equal to del square z by del y del x. When we interchange these two, then the value is equal. And again variable to be treated as constant and some representing skill of this variable to be treated as constant, and two examples that are based upon partial derivatives, and again one example that relate to variable to be treated as constant in terms of partial derivatives. So with this valuable video lecture, let me wind up this session. Thank you.